today we are dealing with absolute value equations. So the first thing we have to remember dealing with our absolute value equations is the fact that the absolute value is your distance from zero. So if you remember on your number line, your distance from zero is the same whether you're at positive 3 or negative 3. We are still 3 units from 0. Even though my picture is not the best and it's not equal, it's still 3 units from 0. So that's the main thing we have to remember. So when we're dealing with the absolute value of x, inside these absolute value bars, we really could have two answers. If x is a positive, it's going to give us the x when we take the absolute value of it. If we also have a negative x in there, we also would get a positive x when we take the absolute value of it. So when we're dealing with absolute value equations, we're really going to end up getting two answers. Because you have to be able to take the positive inside the absolute value bars, and you have to take the negative inside the absolute value bars. So when we are solving our equations down here, first thing we need to do is we need to isolate the absolute value. So that means anything that's with it on the outside of the absolute value bars, you've got to make sure it gets moved over to the other side. So anything that needs to get subtracted or multiplied needs to be dealt with first. Then you're going to create two equations. One of your equations will be as the equation as it is without the absolute value bars. And then the second equation, you're going to set it equal to the negative version of the answer. And then our third step would just be solve both equations and get your answers. So let's take a look at our example up here. We have absolute value of y minus 3 equals a 5. So again, that means anything inside this absolute value bars can equal a positive 5, or the stuff inside the absolute value bars can equal a negative 5. So once we create our two equations, which is positive version and the negative version of your answer, then you just go ahead and solve your equation. So here I would add my 3 over. I get y equals 8. This side I would add my 3 over, and I get y equals negative 2. So then what you want to do is you always want to go back and check, because this isn't always going to work. Sometimes you're going to have to reject some of your answers. So if I plug in an 8, I get absolute value of 5 equals 5, which is true. 5 equals 5, so our 8 is good. If we plug in our negative 2, oops, we're running out of space. I get a negative 5 inside my absolute value bar, so yes, that one also does work. So we get to keep both of our answers this time. So if we take a look at example number 1, we don't have our absolute value on its own. We have a 3/2 out here in front. So we need to take care of that first. So I'm going to flip my fraction and multiply both sides times 2/3. So when I do, that gives me absolute value of x minus 4 equals a negative 6. Negative 9 times 2/3 gives me a negative 6. Now I've isolated my absolute value, so I can create my two equations. Except that this one's a different scenario. Can you ever have your absolute value equal to a negative? The answer would be no. So this is an example of a no solution. If you remember, we always said absolute value takes a negative and turns it positive, or it keeps a positive positive, because it's your distance from 0. Your distance from 0 can never be a negative. So if you have your absolute value, once you've isolated it, and it's equal to a negative number, that means we have no solution. There is no answer to that one. Okay, taking a look at example number 2. So we're going to subtract our 3, try to isolate our absolute value sign. We get 2x minus 3. So we don't have it equal to a negative like we did in that first example. So I'm going to create my two equations. X minus 5 equals 2x minus 3. And then x minus 5 equals negative 2x plus 3. When you have a binomial here, you change both their signs when you take the negative version of it. So then I'm going to add my 3 over and subtract my x over, so I get negative 2 equals x is one of my answers. On the other equation, I'm going to add my 2x over, add my 5 over, so I get 3x equals an 8. Divide by 3, so I get x equals 2.6, repeating. So again, you need to do a check, make sure these answers work. So I'm going to check my negative 2 first. So in my absolute value bars, I get a negative 7. Take the absolute value of it, I get a positive 7. And here I get 10 equals negative 4, which is not true. So this is actually an extraneous answer. So then over here, I'm also going to try my other answer. But I'm going to leave it as 8/3 when I go to plug it in for my check. So I have 3 plus 7/3. This would be a negative 7/3, but becomes a positive 7/3. And I accidentally write 7/5, 7/3. And then this over here gives me a 16/3. Now 3/3 is the same as 9/3. So now I can add my fractions and I get 16/3 equals 16/3. So that checks out. So our answer for that one is this. So you can leave it as 2.6 repeating or 8/3. So for example number 3, again, first step, we have to isolate our absolute value. So I'm going to add my 2 over, and I get a 14. And then I got to get rid of the 7, so I have to divide by 7. So I get absolute value of 3x minus 8 equals a 2. So now we can create our two equations. 3x minus 8 equals 2, and 3x minus 8 equals a negative 2. So I'm going to add my 8 over, and I get a 10. Divide by 3, and I get 10/3. Or you could write it as the decimal form of it, which would be 3.3 repeating. Over on the other side, add my 8 over, and I get a 6. Divide by 3, and I get a 2. So again, we have to do our check. So 7, and then it's 3 times 10/3 minus 8. We're going to see if that, or minus 2, we're going to see if that equals a 12. It's kind of messy, but that's what happens. So this would give us 10 minus 8, 2 minus 2. We're going to see if that equals 12. So I have 14 minus 2 equals 12, and that does work. So 10/3 does work. So now we need to check to see if our 2 works. We got to do 3 times 2 minus 8 minus 2, see if that gives us 12. So this gives me a 6. Minus 8 is negative 2. But take the absolute value of it, I get a positive 2. So again, yes, I'm going to get that this checks. I get 12 equals 12. So we get to keep both of our answers this time. And then for the fourth one, again, isolate the absolute value, but our absolute value is already on its own. So I'm going to go ahead and set up my two equations where it equals a 1 and it equals a negative 1. So then I'm going to do times 5 to get rid of my fraction. And then I'm going to add my 7 over and divide by 2. So I get y equals 6. Over here, again, times 5. So I get 2y equals 6. 2y minus 7 equals negative 5. Add my 7. Divide by 2. So y equals 1 is my other answer. So then we need to do our checks. If I plug in a 6, that gives me 12 minus 7 over 5. We're going to see if that equals a 1. So 12 minus 7 gives me 5. 5 over 5 gives me a 1. So yes, a 1 equals 1. That checks out. So now we're going to try our 1 over here. We're going to plug in a 1. So that would give me 2 minus 7 over 5. See if that equals 1. So this gives me a negative 5. Negative 5 over 5 is a negative 1. And when you take the absolute value of it, yes, 1 equals 1. Lots of work on these ones, I understand that, but this is how we solve them. So sometimes we'll get no solution if it's equal to a negative, like this one was. Sometimes you'll get 2 solutions. Sometimes you have to reject one of your solutions. It's all like the stuff we've been doing before. Let's take a look on the back. Absolute value inequalities are just like our absolute value equations. There's just one extra step to it. So first, again, you want to isolate your absolute value. That's the same step as with our regular equations. Second step, you want to create your 2 inequalities. This is where the extra little step comes into play, and I'll show you when we do our first example over there. And then step 3, solve, and 4, check your answers, see if they work. We always need to do a check. So, what we need to do when we create our 2 inequalities, like this one we already have our absolute value on its own. So we create our first inequality just like it's written, just we drop our absolute value bars. But when we take the second inequality, you need to flip your sign when you set it equal to negative 3. Because if you remember, when we multiply or divide by a negative, our sign flips. So it follows the same rule. Your sign flips when you set it equal to the negative version of the answer. And then you just go ahead and you solve. So here we would have x is less than 5. When I add my 2 over, here I add my 2 over, I get x is greater than negative 1. So if we were to take a look at this on the number line, here's my negative 1, here's my 5. I would have open circles on negative 1 and 5 because it doesn't have the or equal to. And so then x has to be less than 5, so it would go this way, and greater than negative 1. So this one would be shaded in the middle. A lot of times they're going to ask you for the inequality to answer this, and so you would write it like this, where negative 1 is less than x is less than 5. Since the shading is in between the 2 numbers, the x is in between the 2 numbers. Now another way you could write it, instead of writing it like this, is you could have like what we have up above, but you would have to write the word and in between them. Again, when the shading is in the middle, it's an and, because you can be in both places. You can be less than 5 and greater than negative 1 at the same time. And actually, on the Regents exam, they made us take points off if they didn't include that word and. So either of those 2 ways are acceptable ways of writing your solution. Okay, number 2. Let's try this one. Isolate the absolute value. We've already done that, so we don't need to do that anymore. So now we need to create our 2 inequalities. So this one, when I take the negative version of the answer, I'm going to flip my inequality, make it a less than or equal to. So now we'll solve these. Subtract my 6 over, and I get a 1. Divide by negative 7, my inequality is going to flip, and I get x is less than or equal to negative 1/7. Over here on the other side, again, subtract my 6, I get a negative 13. Divide by negative 7, and I get a 13 over 7. Since I'm dividing by a negative, remember this negative and the other negative turn the whole thing positive. So graphing on the number line, here's my negative 1/7 approximately, here's my 13 over 7 approximately. This time, close circles, because I've got the or equal to, so they're going to be closed circles with the number line. So here, x is less than negative 1/7. So I have to shade actually this way. Less than is always shaded to the left. And then x is greater than 13/7, so this one gets shaded that way. Greater than is always to the right. So if we were to write this one in inequality notation, really there's only one way to write it. You would have to write x is less than or equal to negative 1/7, or x is greater than or equal to 13/7. This one is an or because you can't be in both places at once. You're either here or you're here. You can't be doing both of those answers at the same time, so that one has to be an or. Again, on the regents, they took points off if you did not write it as an or. So you got to make sure to remember to write the and or the or. So again, number 3, absolute values already isolated, so I'm going to create my two inequalities. And then 3x minus 2/4 is less than negative 5. So I'm going to go ahead and solve my one over here on the left. So times 4 by 3x minus 2 is greater than 20. And my 2 and divide by 3. So again, we could write it as 7.3 repeating. You could leave it as the fraction 22/3. Either one works. Over here, times 4. 3x minus 2 is less than negative 20. Add my 2. Divide by 3. So I get x is less than negative 6. I'm going to draw my number line. Negative 6. Positive 7.3 repeating. Both of them are going to have open circles. So now I have to figure out my shading. X is greater than 7.3, so I've got to shade to the right. Greater than is always to the right. And then x is less than negative 6, so I'm going to shade to the left for less than. So this one, we have to write the inequality like we did for the last one. X is greater than 7.3, or x is less than negative 6. You just got to remember to put that word or in there. And then taking a look at our last example, they want us to select the inequality whose solution is pictured in the graph. So looking at the graph, first thing I notice is the fact that I have closed circles here. So I know right away it's not going to be choice C or choice D. So now I've got it narrowed down at least a little bit to choice A or choice B. So really, all you're going to do is you're just going to kind of pick one and try it. So for the first one, I'm going to set up my inequalities, remembering to flip and negate. So over here I get x is less than 5, x is greater than or equal to negative 1. So if I take a look at my picture though, I have negative 5 and positive 1. Those weren't my answers. So that tells me it's going to be choice B.